Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/43 for the session October November 24. And we are going to solve the last of all questions of this paper, which is two particles A and B of masses 3 kg and 5 kg respectively are connected by a light inextensible string that passes over a fixed smooth pulley. The particles are held with the string taut and its straight parts vertical. Particle A is 1 meter above the horizontal line and particle B is 2 meter above the plane. The particles are released from rest. In the subsequent motion, A doesn't reach the pulley, and after B reaches the plane, it remains in contact with the plane. Find the tension in the string and the time taken for B to reach the plane. Well, the diagram is given there, and from this question we understood that two values are missing. Two values are to be obtained, and they are the tension in between the particles, I mean in the string, and the acceleration of the particles. So as there are two values to be obtained, we will have to form two equations simultaneously, and they will have to be solved simultaneously. And initially, we are sure that we are going to apply the concept of the motion law of Newton for solving such common and easy solutions. So let us start our solution. If we apply the concept of the motion law of Newton, it is, if we talk about P, I mean A, particle A, look at this. If the particles are released, A will move up. Look at this. A will move up, whereas B will move down, because mass of particle B is more than the mass of the particle of A. So after release, surely A went up and B moved down. First of all, as we have already decided that we will have to form two equations. First, taking A into consideration, let us form an equation. For A, for particle A, we have already decided that particle A will move up. So it is, the concept we are going to apply is driving force minus resistance force is equal to mass into acceleration. Well, let us find out the driving force which is causing the particle A to move up. It is nothing but the tension in the string. Actually, tension is moving particle A up. So driving force is T, tension T. Then there is no other force which is causing the particle move up, and the opposite force, I mean resistance to motion, is weight. Only weight is the resistance to motion. Weight is causing, trying to move it. Weight is trying to, let me show you, weight is trying to move the particle downward. So weight is the only resistance force. So how do we resolve the weight? We resolve weight mg cos 0 degree. You can ignore cos theta because angle is here 0 degree in terms of right angle triangle, and mass of particle A is 3, acceleration is A. After that, it is going to be T minus mass of particle A is 3, acceleration due to gravity is 10, and cos 0 is 1 equal to 3A. Hence our A is, if we make A as subject, A is equal to T minus 30 over 3. we may leave this as equation number 1. Then for particle B, for particle B, particle B. Well, for particle B will move downward, and the concept we are going to apply is same. Driving force minus resistance force is equal to mass into acceleration. Driving force is, let us see from the diagram what is the driving force for B. Look at this, there is nothing but weight which is causing it moving downward. So the resultant force of weight is the driving force for B. So we will write weight is mg cos 0 degree minus resistance to motion is nothing but tension for B, equal to mass of the particle B was 5, so it's 5a. After that, if we substitute the values, mass of the particle B is 5, acceleration due to gravity is 10, and cos 0 is equal to 1, minus t is equal to 5a. Hence our a is, if we isolate a is equal to 5 tens are 50 over 50 minus t over 5. As we have already decided that there will be two equations, we have formed both the equations, and in both of the equations the left side is nothing but a. So a is equal to this. Then if we resolve the forces simultaneously, it will be, let us see what are the equation. Let me write on the left side. A is equal to, first equation was, let's see, yes, over here look at this, this is the first equation. First equation was this, whereas the last equation, I mean second equation, is this. So how to write, and both of them are having a on the left side, we are going to write that t minus 30 over 3 is equal to 50 minus t over 5. After doing cross multiplication, we will get 5t minus 150 is equal to 350, 150 minus 3t. If we simplify 5t minus 3, that means positive, it will be 8t. 8t is equal to 150 plus 150 means 300. Hence our t is going to be, if we divide 300 by 8, it is going to be 37.5, 240 and 37.5. So tension in the string is 37.5 Newton. We have already got the first part of the solution, I mean first part of the answer. Then they have told us to find, the second part is find the time taken for B to reach the plane. Well, so if we find the time, if we want to find the time, we will apply the formula of Shubert formula. And in Shubert formula, the components are S U V A T. Okay, that means displacement is known to us from the graph, from the diagram we can see that it is actually 2 meter. When B reaches the ground, the distance is 2 meters. So S is given to us, and then initial velocity, it was released from rest, initial velocity was 0. Then time is to be obtained, then acceleration is required. So let us find the acceleration. Acceleration is missing, so if we find acceleration, let me write over here. Okay, acceleration, first of all, this is the part of solution, second part of the same solution. So acceleration is equal to, a is equal to, from any of the equation we can apply the value. Look at this, in first equation acceleration is t minus 30 over 3. So it is T minus 30. T is tension. Tension has already been obtained. What is the tension? We have obtained the tension in the string is 37.5 Newton. So let us write 37.5 Newton minus 30 over 3. So it is actually 7.5. If we divide 7.5 by 3, it is going to be 2.5. 2.5. Well, and we are to find the time, and S is equal to ut plus half a t squared. Okay, S is the displacement. We have seen that the displacement traveled by B when it reaches the ground is 2. And initial velocity was 0. So it is 0 plus half of acceleration. Acceleration is, we have obtained acceleration is 2.5 meter per second square. Okay. So 2.5 then t square. T square. As we are to find t as subjects, so 2.5 over 2, that is 1 point, it is going to be 1.25. So it is square root over t is equal to, if we use it simply, it is 2 over, and half of 2.5 is 1.25. Okay, so our time is going to be, if we divide square root of 2 divided by 1.25, it is going to be 1.264. That means if we round it up to three significant figures, it is going to be 1.26, 1.26 second, 6 second. So that is what we should find as the time second. Okay, and that is the final answer. We can write here answer notation, answer. Okay, so we have already obtained both the answers. One of the answers was tension was 37.5 Newton, whereas the time taken by B to reach the ground was 1.26 seconds. There is nothing complicated and difficult in this solution. So let's move on to the next part of the question. Next part says, find the time for which A is at least 3.2 meter above the plane. Means, let us go back to the question. This is the diagram. If we analyze the diagram, look at this. Already particle A, let me erase this unnecessary part. Look, already particle A is above 1 meter, and when B reaches the ground, so already A is above 1 meter, and when B reaches ground, then it is above 2 meter. So 2 meter, then total 3 meters have already been traveled by A when B reaches the ground, and they have told us to find that the distance should be, here it is written, look, it is written that find the time for which A is at least 3.25 meter above. So 3.25 meter should be the distance. For this, already A has traveled, traveled 3 meters. So A should travel 3.25 minus 1 plus 2. So actually A will have to travel 0.25 meter as the distance. So they have told us to find the time when the particle was at least 0.25 meter, but there is a little twist in between them in this question. The twist is, look at this, they have told us to find the time. It's actually, they try to make us understand that at one stage A was moving up. Okay, suppose here there is A, and here 3 meter above, no, not over here. Suppose A was over here. When B reaches the ground, A is at this point. That means this is 3 meter. Length is, this height is 3 meter. After that, when B reaches the ground, then what happened? We know that A was moving upward, and at one stage, suppose here A was moving up and coming down, surely coming down, because there is no driving force acting on A at all. So what is this? Actually, they have told us to find the time in between this. Suppose this one is 3 meters and 0.25 meters. After reaching 0.25 meters, 0.25 meters, 0.25 meters, and this is the highest point. After reaching that height, again A came back to this height. Okay, that means they have told us to find the time when the particle was moving up and coming down, and this height is 0.25 meter above this point, the initial point of A. Okay, so for this, what we will do, first of all, we should know the velocity of B. When velocity of B, this was for B, suppose here this is the ground, so B reached the ground, here it is about B. Okay, so let us see what was the initial velocity of B, I mean final velocity for B when B reaches the ground. It will be the final velocity for B, whereas when A was moving up in the second phase, that will be the initial velocity of for A. So we will write here velocity, final velocity, initial velocity of A. Let us write in terms of A. Initial velocity of A when B reaches the ground. B reaches the ground. Reaches ground. And we know that formula is very simple. That is, v square is equal to u square plus 2as. Okay, so final velocity is to be obtained. V is equal to initial velocity, both the particles were released from rest, so it is 0, plus acceleration was 2.5. From the previous question we get this, and s is 2 meters because B traveled a distance of 2 meters when reaches the ground. Hence our, it is v is equal to square root over this. Hence our v is going to be square root over 10 meter per second. 10 meter per second. When B reaches the ground, A was still moving up. As I have shown you, when B reaches the ground, A still moved up, and at one stage it came down. Okay, now we should know the acceleration of A when B reaches the ground. Okay, and for that, for finding acceleration, we apply the simple concept of motion law of Newton. So for, if we write it in word, acceleration of A, for acceleration of A when B reaches ground. When B reaches ground. Okay, and we apply the simple concept of, for acceleration we apply the simple concept of motion law of Newton, that is driving force minus resistance force is equal to mass into acceleration. So driving force is nothing, look at this, when B reaches the ground, there is no, let me show you. Look, when B is at this point, B came here, then there is no more tension acting in the string. So A itself moved up. So there is no driving force for A when A was moving up when B reaches the ground. Well, so we will write that there is no driving force, but resistance force is mg cos 0 degree, because this is vertically hanging vertically downward or upward. Sorry, cos 0 degree, not 30 degree, cos 0 degree. Cos 0 degree is equal to mass of particle A is 3 and we are searching for acceleration. So our A is going to be 3 over negative mass of the particle A is 3, acceleration due to gravity is 10, cos 0 is 1. Hence A is going to be negative 10 meter per second, meter per second square. Well, this is the acceleration when A was moving up after B reaches the ground. Well, then we have already understood that when B reaches the ground, A was still moving up. A was still moving up, and they have told us at one stage, at greatest height, surely A will stop moving up and it will come down again. They have told us to find that how long was the particle above 0.25 meter. That means after these three should not be included. The question is above this. Okay, so we have already got, what did we get? Look at this, we have got the initial velocity for A and acceleration as well as acceleration of particle A. So simply we can apply the formula of kinematics, that is s equal to ut plus half a t square. Okay, so S is, we have already decided that 3 meters have already been traveled by each of A and B. So there remains only 0.25 meters. So 0.25 is equal to initial velocity has already been obtained. It is 10. So 10t. It is no more positive because acceleration was negative. So negative 10 half of 10 into t square. T square. Then if we simplify this, 2 5s are 10, so 5t square, 5t square minus 10t plus 0.25 plus 0.25 is equal to 0. Applying the quadratic formula, we get that t is equal to, let me zoom it out, t is equal to negative b. How much is our b? B is square root of 10. Sorry, here we have written it's not 10, it was square root over 10. Look at this, initial velocity of v was square root over 10. So this is square root over 10. So our v is square root over 10 square root over 10. Let me see whether we have written the equation properly. Yes, 5t square minus square root over 10t plus 0.25. So our v is, t is square root over 10, then negative positive, v square is 10 square, so 10 minus 4ac. A was 0.5 and c was 0.25. Okay, under square root, and 2a was our 5. Let it not be the final step, hence t is equal to, if we calculate using our calculator, we will get t is equal to square root over 10 plus square root over 10 minus 20.25, it is 5. So square root over 10 plus square root over 5 over 10 is equal to, first value is, our first value is going to be 0.2699, 0.2699 0.2699 and the second value is, that means when it came back the time was 0.463. They didn't tell us to find the time instant when it reaches 3.2 to 0.25 meter high. They have told us to find the time when it was at least means the time in between them. So we'll write the time is equal to, we will just do the subtraction, 0.2699 minus 0.463. If we do this subtraction, let it be 0, so 9, then 936 from, sorry, we made a little mistake. We should write the greater value at the beginning. Okay, the greater value is our 0.463. So if we rearrange, let it be, suppose this is negative. Okay, this is negative and this is positive. So after that, after subtraction, we will get, so it is 1, and from 3 if we subtract 9 13, so it is 4. Then from 3 if we subtract 9, so it is 26 27. So from 46 if we subtract 26, it is 0.29 0.29. So if we round it up to three significant figures, no, we made a mistake in writing this answer. This should not be like this. Let us use our calculator. Okay, let us use our calculator. The calculator says square root over 10. Yes, square root over 10 minus square root over 5 divided by 10. It is point 0.5398, 0.5398 is the greater result. Then the second value of t, when there is a negative symbol in between them, it is going to be minus, let it be negative symbol, this 0.0, 0.09, 0.0926. So time is going to be, if we do subtraction, 0.5398 minus 0.0926. This is the time when the particle was above 0.25 meter, point 3.25 meter from the ground. So if we do the subtraction from 8, if we subtract 6, it is going to be 2. From 9, if we subtract 2, it is going to be 7. Then from 3 if we subtract 9, it is going to be 4. Then it is going to be 13 and 4, so it is going to be 4. Before that there will be 0. So if we round it up to three significant figures, it is going to be 0.447 seconds. Okay, seconds. This is the time, I mean duration. Actually, there is a twist in the question. They have told us to find the time when the particle was 3.25 meter above. That means at least in the question there is a twist. It has mentioned here that at least 3.25 meter above. That means it is not the exact height that it is from 3.25 meter from the ground. That means it was here, suppose at this point there is 3.25 meter, 3.25 meter from the ground. So the particle went up and reached again at this point. So they have told us to find the time when the particle was in this height. I think you got my point. That's why we have found the first value. First value is point five three nine eight. 5398. When it was that finally it reaches here, that means, and initially when it was at this point, it took the time was 0.0926, 0926. That means when it reaches 3.2 meter height initially over here, then it took 0.926 second. Then again when it reached the same height, the time taken by the particle A was 0.5398. Then they have told us to find the time actually between these two instants, when the duration of time when it was at this height. So it's a twist from the question. Remember, don't get confused. It's a twist. So first it took 3 point, I mean 0.0926 second to reach 3.2 meter above the height. Then again it reached the same height after reaching the highest point. Then it reached the same height, means 3.25 meter above the ground. Again it took 0.5398, and the duration the particle was above 3.25 meter above the ground was 0.44 second, and that is what the answer is. And I tried my level best to explain every tiny part of this solution, and I believe that you have understood it well. So may Allah bless us all with beneficial knowledge. Fi amanillah.